So this is now the next, that is a specific heat of a gas. So what is the specific heat of a gas? So the quantity of heat required to just increase its temperature through 1 degree Celsius. Yeah, so that is what we can call is nothing but specific heat. So in this case, so when you provide the heat to the mass of substance, it might be unit mass of substance or some quantity of mass. So there might be possibility that its volume might get changed or its pressure also get changed. So you have to keep one of the parameter constant, keeping volume constant either, or keeping pressure constant. So that is called as a principal specific heat at a constant volume. If you keep volume constant, if you keep volume constant and you provide the heat, and then its temperature is going to increase through 1 degree Celsius by keeping its volume constant. Similarly, you can define it for your constant pressure also by keeping its pressure constant, and you have to increase the temperature of, let's say, unit mass of a substance through 1 degree Celsius. So that is called as a principal specific heat at a constant pressure. So basically there are two specific heat of a gas. One is your specific heat at a constant volume, and another one you can say that the specific heat at a constant pressure over here. Now we will see what are the limits of a specific heat of a gas. So when we say that, so this Q is equals to mc into delta T. So this Q upon m into delta T is equals to C. Yeah, so that is nothing but the specific heat. So now what will happen if I just compress that gas suddenly? Just compress that gas suddenly, there is no exchange of heat, so the delta Q becomes 0. Yeah, so this is one of the case. So your C obviously becomes 0. Or again in the second case, if I just allow that gas to compress or again to expand at a uniform rate, so that there will not be any change in the temperature, so which will make Q upon m into delta T is equals to, that is C over here. So according to this question again, so if I just keep the value of that delta T over here, so which is 0, so then for this case also this one will become your infinity. So the C value might be 0, infinity, it might be positive, it might be negative. So all those depends on the conditions under which I am going to keep that pressure and volume. So there are few limits on the specific heat of a gas also. Now we will define the two principal specific heats of a gas. The one is molar specific heat at a constant volume. Yeah, so we have seen the previous one that we just called it as a specific heat, so which is related to the mass of a gas. Now for this case it is related to the moles of a gas. So we will just take the quantity in terms of moles. It might be 1 mole or n mole of a gas. Yeah, so based on that, so again we can say that your Q is equals to nc into delta T, where n is nothing but number of moles. Again in this case also there are two molar specific heat. Again the molar specific heat, the amount of heat you need to provide to the 1 mole of a gas so that its temperature is going to increase through 1 degree Celsius, or it is might be n number of moles. So now what we are going to do for this case, so molar specific heat at a constant volume, so increase the temperature through 1 degree Celsius by keeping its volume constant. So that is the molar specific heat at a constant volume. Similarly, the molar specific heat at a constant pressure, keeping its pressure constant, again increase its temperature through 1 degree Celsius. So that is the molar specific heat at a constant pressure.